Okay, this is lesson 1.3.8, writing rules from tables. So far you have been writing rules from patterns, from shapes, like this up here with these different blocks, these growing patterns. So what we're going to do is we're going to start with that, and then we're going to learn how to write rules from tables. So let's look at what we know. So what we've done in the past is we have said, okay, this is step one or figure one. I'll go ahead and just say this is step one. And this then would be step two. And the next growing pattern is our step three. So what we have wanted to do is say, well, how many blocks do we have in each step? So in this first one, we have 1, 2, 3, 4. So we have 4. In the next one, if we count, it looks like it's doubled. We have 1, 2, 3, 4, 5, 6, 7, 8. And in the last one, now it's tripled. It looks like we have 12. So what we've done in the past is tried to figure out some sort of expression to represent this growth. But it's a lot easier if we can take that and put it into a table. So what I'm going to do is say, all right, step one, we're going to say that that represents x. Okay, so the steps are our x. And we're going to say the output, the number of blocks that we have, we're going to say that's our y. And that way we can put it in the table a little bit easier. So we'll put x's here, we'll put our y's here. And then we'll just record what we have. So on our first step, we said we had 4. And on our second step, we said 8. And on the third step, you have 12. So notice that each of these is sequential. Our steps go up by 1 each time. As long as we have that, then all we need to do is look at the change in the number of blocks. So let's change colors. Going from 1 to 2, we went up 4 blocks. Going from 2 to 3, we also went up 4 blocks. That's a constant change, which means that it's a linear pattern. So we can write an expression to represent that. So we know that if x represents what step we're on, that if we multiply x by 4, because we grew by 4 each time, that will tell us how many blocks we have in each step. So if we say that this 4x represents our rule, let's test it out. So let's try it with step 2. So if we put a 2 in here, 4 times 2 is 8. That's how many blocks we have. That works great. Let's try step 3. So if we put a 3 in here, 4 times 3 is 12, and that's how many blocks we have. That works. So 4x then represents our rule. So we have written a rule from the pattern of blocks and transferred it to the table. Now let's try some harder ones. Let's just look at tables this time. Okay, so if we notice that the x value, that represents our step, right? Or what figure we have, and they're all sequential. 0, 1, 2, 3, 4, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, and 5, 6, 7, 8, 9, all sequential. So all we need to do is look at the change in the number of blocks or tiles, or basically it's our y value. So if we take the first one, 2 to 5, that's an increase of 3. And it's important to notice whether it's going up or going down, because that will change what we multiply our x by. 5 to 8, that's also 3. 8 to 11, again 3. And 11 to 14, I bet will be 3 as well. So we have an increase of 3 every time. So if we're going to write an expression then for this, we would say that we would multiply our x term by 3 every time to get the right answer. So let's try that actually. So let's start with 1, like we did the last time. So 3 times 1 is 3, but our y value is 5. That doesn't work out. Let's try it with the 2. 3 times 2 is 6, but our y value is 8. That also doesn't work out. Let's try the 0. 3 times 0 is 0, but our y value is 2. Are you guys starting to see a pattern? So what do we need to do to get this y value? Okay, because we know that the increase is 3. So we know we multiply the x term by 3, but we still need to get this ending y value. So let's look at back with the 1. 3 times 1 is 3. How do we get to 5? Well, if we add 2, we can get to 5. So now let's try it with something else. Let's try it with the 3. Okay, so if we plug in a 3, 3 times 3 is 9, plus 2 is 11. Try it with the 4. 4 times 3 is 12, plus 2 is 14. So here we have it. Here is our rule. Okay. So when you're making your rules from your tables, you always look at that change, that increase or that decrease in your y value, as long as your x value is sequential. Okay, so let's try the next one. So if we go from 1 to 3, that's a change of 2. If we go to 3 to 5, that's also a change of 2. So I would suspect that all these are an increase of 2 each time. So that's easy for us to figure out that growth. So that growth is going to be 2 times x. But then we always need to try it to figure out what we need to do in order to actually get that y value. So let's try the 3. All right, so we have 3 times 2 is 6, but if you'll notice, the y value is only 1. What do we need to do to 6 to get down to 1? Okay, so think about that. Let's look at the 4. So if we plug the 4 in for x, you have 2 times 4 is 8, but our y value is actually 3. What do we need to do to get down to 3? So by this point, you're thinking, sounds like subtract 5. So if we go over here and we put a minus 5, let's make sure we're correct. So we can plug in the 3. 3 times 2 is 6, minus 5, hey, that equals 1. Let's go up here to the 7. 7 times 2 is 14, minus 5, that equals 9. So after a couple of tests, I would say 2x minus 5 is our rule that represents that table. Okay, so if I were you, I would pause the tape and I would try this third one on your own and then start it again and we'll do it together. All right, so let's see if your answer matches mine. So let's look at the increase. To go from -4 to 1, that's an increase of 5, right? You got to go 4 to get to 0, plus 1 is 5. 1 to 6 is 5. And these are all going to be an increase of 5. And remember that that constant increase means it's a linear pattern. If we were to graph this, it's going to make a straight line. So we have a constant rate of change of 5. So let's create our rule. So we know we are going to have a 5x, but then we have to figure out, do we have anything on the end or is 5x fine? So let's test it out. Let's plug in a 2 for x. So 5 times 2 is 10, but we have 1. What do we need to do to get down to 1? From 10, we have to subtract 9. But let's make sure, let's test it out with another one. So let's plug in the 4. 5 times 4 is 20, and if we subtract 9, do we get 11? We do. So our rule is 5x minus 9. And let's try the last one. So again, if you want to, this is a little bit more tricky, but if you want to give it a try and then pause the tape, and then when you come back, we'll see if you have the same rule as I do. Okay, so let's look at what we have here. We are not increasing anymore, we are decreasing. We are going from 7 to 1. So what did we do? We subtracted 6 this time. When we go from 1 to -5, what are we doing? We are subtracting 6 again. If you'll notice that our pattern now is subtraction. And in the past, we've just had addition, right? We've grown by a certain number, and now we are decreasing by a certain number. That doesn't really change anything. So when we make our rule, instead of having 6 times x, because we are decreasing, we're going to have a minus 6 times x. So let's plug that in and see what we need to do to get to our numbers. So we have 5 times -6, and think about, okay, so 5 times -6, and I'll write it out down below just because we have a little bit more math. So 5 times -6 is going to be -30. Well, we need to get to 7, right? So what do we need to do to -30 to get to 7? Looks like you would have to add positive 37 to -30, and that would get you the 7. So let's add that to our rule. Check it and make sure it works. So we would add a positive 37 and see if that's our rule. So let's try another number. Let's try 6. Okay, -6 times 6 is going to be -36. What happens when you take -36 plus 37? You get +1, which is what we were supposed to get. So this is indeed going to be our rule. All right. So now you have a quiz, a practice quiz, where you get to try a few of these on your own, about 4 of them. So give that a try. That's on the next page.